Hello and welcome to Morehouse's Math Menagerie. Today we're going to be talking about correlation. But before we begin, I wanted to show you this very interesting piece of art that was created by a company named Obvious using artificial intelligence. Correlation deals with what we call bivariate data. Up until now in this course, we've been dealing with one data set at a time. That's called univariate data. We're going to be using this data set throughout this video. You might want to pause the video now and put this into your calculator, putting sprint times into list 1 and long jump distances into list 2. When we are talking about bivariate data, since there are two separate variables that we've collected from each individual, we need to be able to talk about them separately. The response variable is the measure of an outcome of a study, while the explanatory variable is used to predict or explain changes in a response variable. So for the data we have, the explanatory variable would be sprint time, and the response variable would be long jump time. You can think of it as it makes more sense to predict how far somebody can jump based on how fast they run versus predicting how fast they can run based on how far they can jump. In order to visualize the data, we're going to create what is called a scatter plot. So to do this on our calculator, we're first going to go to stat plot. We're going to make sure plot 1 is turned on and then select the very first plot type. You can see a bunch of dots there. Make sure that list 1 is in our X list and list 2 is in our Y list. If you hit stat and then go down to stat zoom, you should get a graph that looks like this. Remember that the explanatory variable is always going to go on the x-axis, and the response variable is always going to go on the y-axis. You can see in the scatter plot that there tends to be a linear pattern that shows the longer it takes you to run 40 yards. So the slower you run, the shorter your jumping distance is in feet. Now, to actually measure this relationship, we're going to use what's called correlation. Correlation is a number that measures the direction and strength of a linear relationship between two quantitative variables. Correlation can be anywhere from -1 to +1. In the middle at 0, it means there is no linear association. But the closer R gets to either -1 or to +1, the stronger the association is. At about 0.3 for an R value, we'd say there is weak association. 0.5, we'd say about moderate association. 0.7 is strong association, and then 1 is perfect association. Here is the formula for how R is calculated. You will not need to use this formula to calculate R. I just wanted to show it to you so you can see what goes into the calculations. Now, a few facts about R is that R is calculated using standardized values for both variables. That's both the explanatory and response variable. And you'll recall from our previous conversations that standardized values do not have a unit of measurement. Thus, unit of measurements do not affect R. If we decided to measure our long jumps in meters or in inches instead of feet, the R value would still be the same. Correlation only describes linear relationships. If we have some sort of curved relationship like exponential or logarithmic, it is not going to be relevant. The correlation coefficient is not resistant to extreme values. So any sort of outliers or extreme values are going to have a large influence on the R calculation. And while correlation helps us understand the association between two variables, it is not a complete summary of what is going on between two variables in a data set. Here are some examples of correlation. Here we have a correlation of R equals 0. This would be no linear association whatsoever. You can see here we have some weak association with an R of -0.3. You start to see a little bit of a pattern there. You'll notice it's going in a negative slope direction. As our R gets a little bit closer to -1 there at -0.7, you can see this is a strong association. We're seeing a definite, well-defined linear pattern in the data. For a correlation of R equals 0.5, this is a moderate association, so there's a little bit of pattern, but it's not quite as strong as the 0.7 in the previous scatter plot. Now, as R gets close to 1, so at 0.9, you see a very strong line. The dots are very close together. And then when correlation gets very close to 1 at -0.99, you can see that it is almost a perfect line within the data. Now that we know what correlation is, it is a measure of the strength, and it tells us the direction of an association between two variables. We need to look at how do we calculate it. So the first thing you're going to have to do, and you only have to do this once, is we need to go to our catalog and turn on a setting within the calculator. So click on second 0, that'll take you to the catalog. Scroll down to diagnostic on. After selecting diagnostic on, hit enter until you see this done screen. Now, once you've done this once, you never have to do this for your calculator again unless you end up resetting the system. If you reset the system, you're going to want to come back in here and turn the diagnostic back on again. So as for actually calculating correlation, we're going to go to Stat and then scroll over once to Calc. We've been here before to find the one var stats. You're going to scroll down to number 8. You'll see it says linreg A plus BX. We want to select number 8. It'll ask for an X list, which is our list 1, and a Y list, which is list 2. Leave the frequency list blank and go ahead and scroll down and hit calculate. When you hit calculate, you should get a screen like this. If you do not have the R squared and the R variables at the bottom of this output, it means you do not have your diagnostics turned on. Go back to the previous point in this video and turn those on now. R is the correlation coefficient here in this output. It's the bottom number at -0.8378. To interpret this value, we would say that the association between sprint time and long jump distance is strong, negative, and linear. Thank you for watching this video. I will leave you with a quote from Viktor Franklin. Have a great day.